All right, guys, we're ready for our last video about factoring. I don't know if you've noticed, but all of our directions when we're doing our homework always say to factor completely, which means to factor as much as humanly possible. Now, sometimes that means we're just going to factor it once and then we're going to be done. But there is a possibility that you'll have to factor something multiple times. Every time you factor it a new time, you're going to get a new part to your answer. So we start with our original question, and then after the first time that we factor it, we get two things being multiplied together. Most of the time, it's two parentheses. Sometimes, though, it's a GCF times a parentheses. If we have to factor again, instead of having two parentheses, then we'll have three parentheses. If we have to factor again, then we'll have four parentheses for our answer. So just every time that you factor, it adds a new component to your answer. Now, to make sure that we are factoring completely and to make sure that we're using the right methods, we're going to create a chart on the back of your factoring book. So if you have your factoring book, we've filled out the entire front part at this point in time, but there should be a back that's completely empty. So we're going to make a chart on the back of here. If you're just using regular lined paper, go ahead and grab a new piece of lined paper for this chart. You can see the basic layout of the chart on the screen right now. So you need to be able to fit this entire thing onto the back of this paper, right? So if you want to pause the video and sketch it out right now, totally fine. And then I'm going to go through this flow chart with you so that we can make sure that we're factoring correctly and completely. We're going to start at the top of the flowchart, which says first. And the first thing that we should check for on any factoring problem, doesn't matter, like every factoring problem in the world, the first thing you always want to check for is, does it have a GCF? If it has a GCF, you should factor that out first. It's going to make the rest of the problem a lot easier because it's going to make your number smaller. Now, the GCF does still need to be part of your answer. So sometimes what I do is if we were taking a paper quiz or test, I would write the GCF on the answer line as soon as I find it to remind myself that it needs to be part of the answer. Or you could also just type it onto your Delta Math when you're doing your Delta Math. Type in the GCF so that you remember to put it as part of your answer. If it has a GCF and you've factored it out, that doesn't mean that you're done. You do need to keep going. Or if it doesn't have a GCF, you would continue to go. For all of our other types of factoring, it matters how big the original problem is. And so the next thing you need to ask yourself is, how many terms does this polynomial have? The most common sized polynomial for factoring problems is a trinomial with 3 terms. So let's talk about that one first. If you notice that there is a trinomial, 3 terms, and it is a perfect square trinomial, that's probably the fastest way to factor a trinomial if you can be guaranteed that it's perfect square. Perfect square is going to be important in our next half of this chapter. And also, it's important if the numbers are really big. So we had that one example last week with like 121 and 49, and they were ginormous numbers. And on that type of problem, you definitely want to check for a perfect square. Otherwise, if you can't tell if it's a perfect square, or if you even want to just skip that step, every trinomial should be done using Xbox. Okay, so try Xbox. Sometimes it works, sometimes it doesn't. Most of the time it does work. There are some times where it doesn't. So those are the 2 different ways that you can factor a trinomial. If instead you decide that it is a binomial, something with only 2 terms, then you need to decide, are the terms perfect squares or are the terms perfect cubes? Because we have different factoring for squares versus cubes. Squares are numbers that have a square root or have an exponent that's divisible by 2. Cubes have a cube root or a number that's divisible by 3, an exponent that's divisible by 3. If you decide that it is perfect squares, then you're looking for a difference of squares. A difference of squares must have a minus sign, and then this is how you factor it. If you decide instead that it is cubes, exponents that are multiples of 3, then it can be adding or subtracting, doesn't matter. and you sing the song. Now, for the cubes, again, just like all of our other types of factoring, you're taking a problem and you're splitting it into two parentheses. So make sure that you're only getting two parentheses when you're factoring a sum or difference of cubes. The final method of factoring is if you have a polynomial with four terms, and we don't have a special name for that, we just say polynomial with four terms. And if you have a polynomial with four terms, then you're going to use the box method. So these are all the different ways of factoring and how and when you should factor. You do want to keep factoring as long as you have an exponent in, like, even if you have an exponent in your parentheses, you do want to keep factoring it until you can't factor it anymore. That's what factoring completely means. If you've gone through this entire chart and you've decided there's nothing you can do, there's no GCFs, trinomial Xbox doesn't work, binomial, there's no squares, there's no cubes, 4, I put it in the box, it doesn't work, I rearranged it, it still doesn't work, like I've tried everything under the moon, nothing works, can't do it, then you would say that that problem is prime. So the word prime means that it is not factorable. It cannot be changed into a multiplication problem. Think of it like prime numbers, right? If I have the number 12, I can change that into a 2 times 6. But if I have the number 11, I can't change that into different numbers. And so 11 is prime. And same thing with polynomials. If you can't factor it, then it's prime. This is all the information that you need for this unit on how to factor. From here on out, we are just practicing all our different types of factoring and making sure that we can factor completely.